Hello. Hello, am I audible? Hello.
Yes, you're right.
Turn on your mic. I will check my headphones. Hello. Hello. We can wait for a few more minutes. Is it good for everyone? Okay, thank you. Let's wait till 6:05, okay? So then we can start.
Yes,
So, okay, hello everyone. My name is Mohammed Sajid Nazir. I am recently selected as a PMRF student. PMRF is given to the PhD students who are already pursuing their PhD in Tier 1 college or Tier 2 college. So, as a PMRF duty, I have been assigned this course where I will be delivering a lecture. It's not actually a lecture, it's a session where we will discuss some questions based on the previous week. You may all have seen the videos regarding it. Am I right or no?
yes, sir.
Okay, so Mm, it's from my side as an introduction. I work in Nanolab. It's in IIT Kanpur. Okay, so a few things before we start. You can look at the screen. Everyone should mute yourself. That's already a known thing. And if you have any questions during the session, you can drop your questions in chat box, or you can raise your hand if you have to say anything. And you will have to follow the theory properly for the week. And those assignments are different than what we will discuss in this session. Wait a second. And in this session, we will discuss the questions related to the week, but that will be different than what you have been given as an assignment. And the session will be recorded as well, and you can find this session on the YouTube, or the team and NPTEL team will share the YouTube links with you as well. So, okay, second, it's not displaying here. Okay, there is a bit of lag. I'm sharing from other screen. So before we start, you have gone through the session. What what do you understand by, first, before we see KCL and KVL, what do you understand by node? Can anybody answer this? In a circuit, what is the definition for the node? Am I audible?
Sir,
Node
node
means young
is
sum.
Okay, so does everybody understand what node is in a circuit?
yes, sir.
So how do you define a node in a circuit?
So node is a point basically from which another branch emerges from the circuit.
Okay, so node is where we can say the two branches or three branches meet, right? So in the circuit, you can see there are multiple nodes, right? So can you name these nodes? Some are written here.
Sir, V1, V2, V3.
All right. So V1, V2, V3 are three different nodes. And if you look at their bottom side, there is a ground. It is called as a common node, right? So before we go to this question, let's see. Uh, Wait, there is a bit lag. Okay. So what is KCL and what is KVL? Is my screen visible? This slide.
Yes, sir.
Okay. So KCL and KVL, these are Kirchhoff's current law and Kirchhoff's voltage law, right? So current law comes from the conservation of charge, and if we talk about Kirchhoff's voltage law, it is conservation of energy, right? So what is KCL? If you have a node and multiple currents come from different directions, right? So what KCL states that if it is I1, I2, I3, I4, I5, if you sum all these currents, I1 plus I2 plus I3 plus I4 plus I5 and so on, how so many numbers can be there, it sums up to 0. So this follows your conservation of charge, because you define I as a dq by dt. This is definition for current, and here q is charge. So you have heard about this, the charge can neither be created nor destroyed, right? So that is a conservation law, and the Kirchhoff's current law is based on that. Similarly, we have KVL. What does KVL stand for? KVL stands for Kirchhoff's voltage law, right? And it states that if you have a circuit, right, let's say in this figure, if you have this loop, you will see there are two voltages, 15 volt, 1 volt, and there will be some drops across the resistors. You know that, right? the current is flowing in this direction, there will be some drop here, or we can say there is a potential from here to here, similarly here to here, here to here. So what Kirchhoff's voltage law states that if I say this is V1, this is V2, this is V3, wait a second, this is V3, this is V4, and this is V5. What Kirchhoff's voltage law states that is the sum of potentials is equivalent to 0, right? V1 plus V2 and so on to V5 will be equivalent to 0. So this is Kirchhoff's current law and Kirchhoff's voltage law. In this circuit, okay, so okay, now you are able to see this circuit. I will draw this circuit. Okay, now the question in this for this as a starting point is you have this circuit. The second people are joining. You can represent ground like that also. This is a 3 kilo ohm resistor. This is a 14 kilo ohm. This is 2 kilo ohm. And all of these are 2K, 2K. K stands for kilowatt and 2K. This is 15 volt. This is 1 volt. And nodes, as you said properly, these are V1, V2, and V3. So the question is, you have to find this current I flowing through 3 kilo ohm resistor. And let's start with first using a KCL. So KCL is a nodal analysis in which you balance the currents, right? So if we take node 1, node V1, node V1. Oh, okay. So for the node V1, if we take current directions in this way, so the current will be from this potential. This is at 15 volt, this is at 1 V1 volt. So current will be 15 minus, okay, let me first say how you define a current across resistor. Sorry. So current across resistor can be defined as, if you have potential here and if you have potential V1 here, V2 here, you have R here. Wait a second, someone is joining. The current will be defined as V1 minus V2 divided by R. This is simple Ohm's law, right? So if you now look at V1 node, current comes from the 15 minus V1 by 2 kilo ohm, right? And the current comes from V2 minus V1 by 14 kilo ohm, right? And similarly, you have current from this branch, upper branch. Hello. Okay. Please let me know if you are not able to hear my audio. And another branch is V3 minus V1 divided by 3 kilo ohm, and it will sum up equivalent to 0, right? And similarly, if you have this as first equation, You can solve it. You will get 12 by 2k, 15 by, sorry, 15 by 2k minus v1 by 2k. Similarly, v2 by 14k minus v1 by 14k plus v3 by 3k and v. I have solved this question already, and you will see that on solving this properly, you have to just do the simple math. You will find an equation that will be equivalent to 38v1 minus 3v2 minus 14v3 equivalent to 315. Now this is your first equation. Now as you see, there are three variables, v1, v2 and v3. So you will require three equations also to solve to get an answer. So you have to find v1, v2, v3. You need two more equations. So you have to further two more nodes, v2 and v3, right? So what we will do is that you will again do the KCL at these nodes and find another two equations. Please have a note of this circuit. I will write the no KCL at V2. KCL at V2. Now the current, if we take, it depends on you how you define your current directions. If I again define the current directions as all the currents coming to the node, or you can also define as all the currents going away from the node. So it depends on your convention how you define. But as long as you are following the same rule. For example, if I give the current direction from V1 to V2, then you have to write it as V1 minus V2 by 14, not V2 minus V1 by 14. So that should be taken care of. So now if I define at V2, the currents are coming in this way. Now we have V1 minus, who is presenting screen? Please turn off your screen. Gaurav, hello? What is this? Sorry, someone shared his own screen.
Actually, sir, I have a request.
Okay.
Sir, the questions you are discussing, the same questions yesterday ma'am also discussed. So it would be
Yeah,
beneficial.
we have been advised to. Okay, uh, I can look at for the next week, but we have been advised to discuss these assignments. So it's actually if people are not able to, if people are not able to attend the one session, they can attend the next one. So that's why. Hello, am I audible?
Yes, sir, you are audible.
So yeah, so what I can do is that if you want, for example, in next session, I can have some summary of the week you may have studied or something like that. But we are advised to actually teach these assignments that have been prescribed to us. So yes.
So we can do something like the some of the questions were skipped yesterday. You can take those up right now.
Okay, let me complete this one. I have started, then we can look at that.
Okay. Sir.
Okay. So let me go through this quickly then. This is V1 minus V2 by 14k. This will be from V1 and similarly. Okay, let me tell you this. Okay, now you have done this question, right? Everyone?
Yes, sir.
Okay. So you can find the solution. Now let me just show one method of solving this question. Now if you have linear equations, right? Linear equations. That will be helpful for solving the questions for using the KCL and KVL, because ultimately what you get is that you get your linear equations in unknown variables, right? So I will show you one method which will be very helpful for you guys to actually solve this question to get the answers. I can say quickly or something. So if you have equations, let's say you have a1x plus b1y plus c1z equivalent to, let's say, a1, and you have a2x plus b2y plus c2z equivalent to b2, and similarly you have a3x plus b3y plus c3z equivalent to b3. Now you have to solve this equation, right? You will always find, while doing the KVL and KCL, you will find these type of equations at the end where you need to solve this. And many people, what they do is that they will get, let's say, x in terms of y and z and solve two equations, then substitute them in a third equation to get the answer, right? So there is one more method. Where can I find this recorded session afterwards? It will be present on YouTube, and this will be, I think, the NPTEL team themselves, or I will have to make a YouTube channel where this video will be uploaded. Fine. Okay. So what I was saying. So one moment. Okay. Determinants, everyone. Hello.
Yes, sir.
So you have studied matrix and determinants, right?
Yes,
Yes,
sir.
sir.
Yeah, it's one of the methods which can be used to solve these equations very quickly. So if you have to find the determinant, what will write it as? Okay, someone is joining, right? Please correct me if I'm wrong. So we can be in this session together, right? Okay, so this is the main determinant, right? Now, if you have to find the answers for x, y, and z, what you will do is that you will find further three determinants: delta 1, delta 2, and delta 3. Why delta 1 will be equivalent to same determinant, but your first column will be replaced by P1, P2, and Pz. Fine. And similarly, you will find another two determinants where you will replace these respective columns with P1, P2, Pz, and then again, wait a second. And similarly, you will find third determinant by removing this column and replacing it with P1, P2, and P3. When you have delta 1, delta 2, delta 3 in hand, what you can do is that you can, but just remember that for x, you have first variable as x, right? So in delta 1, you will replace first column. In delta 2, you will replace second column that will belong to y. And for third column, you will replace for delta 3. Now, if you have to find x, you will simply write delta 1 by delta, and y is equal to delta 2 by delta, and z equal to delta 3 by delta. Have you seen this method before? I suppose you may have seen this method. Anyone? Hello.
Yes, sir. Yes, sir.
So what is this method called as? Do you know what is this method is called as? Kramer's rule, right? So this method will help you to solve. You can do it for two-dimensional matrix as well. Two-dimensional means where you can have only 2 cross 2 elements, right? So this method is a very easy method, and you can find the answers related to these questions very quickly. So Let's move on now to another question. That is, you you can see my screen, right?
May I interrupt, Shajid?
Yes.
Yeah, please.
Yeah, so myself, Pradeep Mandal from
Oh,
IIT
hi.
Kharagpur.
Hello, sir.
Yeah, yeah. So before you go to the next question, I like to introduce myself that
Okay, sir.
since I am having some time now, so I thought, okay, let me interrupt you and then
Okay, sir.
interact. So I'll request all the people who have not joined yesterday but today have joined
Okay.
to switch on their camera, including yourself, Sajid.
Actually, I'm recording with OBS Studio. I'm
Okay,
not
okay.
able to turn on my video on
No
camera.
problem. No problem. So may I request the other people to switch on their camera?
I will turn my mic off for a second.
Yeah, Vijay Lakshmi. So you have joined today, right?
No, sir, I already joined yesterday also.
Yesterday also. Okay. Yeah. So I have discussed about this course. I am just looking for those people who have joined today, but not yesterday. So Arjun, today you have joined, right?
No, no, sir. I was there yesterday also.
He was there in yesterday's class also. Okay. Yeah, I like to see the other people. Pooja Velavi. On my screen, your name I can see. So, okay. Um, I think Jitesh was there yesterday. Advani, I think Jyoti Advani, I'm not sure whether she was there yesterday.
I, I was there, sir.
You are there, okay. Okay. So, anybody else? You were there yesterday and today have joined. Or let me put the other way. Apart from Sajid, is there any person have joined today? Okay, probably not. Uh, Sajid, I have explained all the participants yesterday while Sarda Devi was discussing about this tutorial problem.
Okay, sir.
And so I do not want to repeat, but just to inform you that along with you and Sarda Devi,
Okay, sir.
in IIT Kharagpur, we do have two more TAs. They are framing the assignment problems.
Okay.
Of course, they discuss with me and finalize the assignment problems.
Okay.
And the purpose, I think, of introducing this interaction is, um, of course, probably engaging new people for this interactive session so that it may be beneficial for the participants.
Yes, sir.
Right? So, for overall synchronization through some other channel, I will request all of you, yourself and Sarda Devi and the two TAs,
Okay.
Tamal Chaudhary and Subramaniam. You can synchronize yourself so that the assignments and those things may be discussed in different forum. Okay,
Okay.
and also you might have been instructed by IIT Madras team. Um these are the questions need to be discussed.
Yes, sir.
So I'll request that, of course, that instruction probably it is a generalized instruction for all the courses.
Mm-hmm.
but we explicitly need to take care of the quality of this course. So if you synchronize with the other two TAs, probably the participants will not see any unwanted repetition.
So, what you are suggesting is that we need not to both TAs need not to deliver the sessions or something like
No,
that.
no. What I'm saying is that suppose yesterday Sardar Devi has discussed some problem,
Yes.
you need not to discuss that because anyway that has been recorded
Mm-hmm.
and it is available to all the participants.
Yes.
Okay. And also, yeah, so probably for first day it is fine, but
Okay.
with progress of time we have to synchronize.
Actually, these kind of things were discussed in the discussion hour with Anfield team, where people
Hmm.
said to them that it will be a
Hmm.
repetition or something like that, but they just said that there are a lot of students who may be able to join one session and may not
Hmm.
be able to join some session, right? So they can join the if there are two TAs, they can join the different sessions.
That's right. That's right. But probably it may be a good idea that in case suppose something already has been discussed and
Mm-hmm.
recorded, and if the recorded version it is available, let the other people, join there. And those the other people who are or for the remaining people,
Yes.
probably you can encourage them to ask new question, and probably we can collect the questions and then we can um, probably discuss those things. Yeah,
So as a PMRF duty, we have to attend the two sessions. So what you are suggesting is that, for example, if the Sharda Devi has discussed the question, next day I will join the session and I will take the inputs from students and discuss related to the week. That will be adjusted.
not really. Suppose you to decide that which are the numerical problems you like to discuss,
Okay.
and better not to have any repetition. I think
Okay.
that
So
is the main
what you're
message.
suggesting as if there is an assignment or
Uh,
something like that, half questions can be discussed by Sharda Devi and half can be discussed by me.
yeah, and let we have some mechanism to collect their queries.
Okay.
Uh, so probably say Monday we collect the questions,
Okay. From the
and
students.
then Tuesday let we discuss.
Okay.
So if something can be discussed on Monday itself, that
Mm-hmm.
is well and good. But suppose some workout is needed, so then we can come back on Tuesday and then we can discuss those things.
Okay.
I think that is what I feel. Yeah, one of the participant raised hand. So may I may I ask that person to speak out?
Yeah.
What was the yeah? What is the suggestion or comment?
This is Bikram Chaudhary. He's kindly explain in Hindi too, sir.
Uh, yeah, what is the query?
Yes, kindly. He says that he wants to listen to Hindi. Maybe he's not so familiar with English.
Hmm. Yeah, where can we find it? Yeah, this is the thing.
Actually, Vikram is asking, sir.
Yes, please. Yeah.
Yeah, previous link he was asking, and he's asking like he wants explanation in Hindi also, if possible.
Oh, okay, okay. Okay, that may be a good thing because I cannot speak in Hindi that well. So probably Sajid, you may take probably you may be comfortable in Hindi.
Yeah, I am comfortable. But I don't know what I am being suggested because I am
Mhm.
bound to. I don't know. uh,
Okay.
uh, I can speak in Hindi, Urdu. I have no issues with that. Let me
Mm.
mail Padma. She is handling the PMRF duty. I can discuss with her. I can mail her. Is there any
Okay.
language barrier to be considered in
Mm.
sessions? And
Okay.
but sir, it's important
Mhm.
for us both that we do these 2 hour sessions. May it be assignments, may it be something else, but we have to give them recorded versions of 2 hours. It's necessary as a part of our PMRF curriculum. So you suggest
We,
it to them.
I think, yeah, I understand your point.
Yes,
So with progress of the session, I'm sure that there will be enough queries.
yes, yes.
And yes, you may be able to record sufficiently on that based on their queries.
Okay.
But just for the sake of spending 2 hours time and recording,
Mm-hmm.
please do not repeat. That is what I like to
Yeah,
say.
yeah.
Or
I
let
got
we
it.
avoid repetition, or even if you want to repeat, let it be one in English, another is in Hindi. So that may be a good idea.
Yeah. We can. I can discuss with Ms. Sharda Devi as well, and if
Mm.
possible, you said that you're synchronized with other TAs. If you can,
Yes. Yes.
I hope you have our email IDs, or you can forward their email IDs. We can have a meeting or something like
Yes, yes, exactly. Yeah. So, Subramaniam, please make a note. Subramaniam is also there.
Yes, sir.
So, please make a note of that, and please synchronize as soon as possible so that.
Yes, sir.
Uh,
I will collect mails from you. I think you have mail IDs of both TAs, PMRF TAs.
yes, yes,
I
yes.
will collect and I will try to arrange a Google
Okay,
Meet.
okay. Okay. So, yeah, today, as you have planned,
that. Yes.
Sajid, please, you may continue. But before I leave, I'll be leaving soon. But before I leave, I just like to hear from the participants so far. What is their observation, or is there any specific comment so that we can improvise the quality of the course?
Sir, just a suggestion.
Yes.
Sir, question number 6 to 10 yesterday ma'am conducted.
Mhm.
They were, I think, 2 or 3 questions were maybe skipped and others were a little fast. So we can go like that, 6 to 10.
Six to 10 questions. Yeah. So, Sajid,
So,
probably you may look into that six to
Okay.
10 questions in depth because probably,
Sure. Sure.
yeah. Yeah, Sharada is also there. Yeah.
yes, sir.
Yeah.
So just wanted to mention. So, yesterday actually we finished all 10 questions. It's just
Mm,
that last question was a little faster, and others were very easy questions. And
mm,
talking about distributing the questions, so yesterday I could finish all the 10 questions
mm,
within, I guess, 1.5 hours. So,
mm,
dividing the questions will like we won't be able to suffice in like 2 hours time. So for 2 hours time, at least we'll need minimum of 10 questions. So as you mentioned, we can go for two sessions, one in Hindi, one in English. That will do.
mm,
Or
mm,
otherwise, students can decide whichever session they want to join. They can join respectively, because anyways dividing questions was I because there is 2 hours time, which is a lot of time. So
mm,
solving all 10 questions properly in 2 hours is like we can deal all the questions very properly in 2 hours.
mm,
So for
mm,
10 hours, yeah, so distribution won't make any like much impact, I feel.
Okay, so I think one in English, another is in Hindi. That will be a better. Uh,
Yes, sir, that we can definitely do. So it will like help the people who want to go for
yes,
Hindi.
yes.
Yeah.
And yeah, Yogesh has raised his hand. Can you please go ahead, Yogesh?
Yes, sir. Where can we find these recorded sessions,
Uh,
afterwards?
it will be available on YouTube.
Yeah, you must. So you will be getting the links shared. So you will get a spreadsheet where you will find all the links, even the documents that we are preparing right now. They are also being uploaded. So you will get the document as well as the YouTube link.
How we'll get that, man?
Uh, is it not shared yet with you people? Like
No,
the drive links? Okay, so
no.
maybe it will be shared very soon. Because we have so yesterday on itself I have uploaded the video as well as like the notes that I prepared while lecture. So you'll find them really soon. If you want me to enter the uh, link here, I can do that as well. Yesterday's recording if you want. So, any
Okay.
other suggestions that we can go forward?
Yeah,
Because,
yeah, yeah.
anyways, we have
So
to finish.
is there any other comment from the participants? Any difficulties?
Sir, I think it would be beneficial if both of the TAs discuss different type of questions, so that we cover every aspect of the syllabus.
Okay. So right now we do have, say, 10 questions to be discussed, and we do have 2 hours on Monday as well as on Tuesday. So according to the TAs, probably 2 hours, probably they can individually they can cover 10 questions on both Monday as well as Tuesday.
Yes.
So that is the present situation. But I'm sure that with progress of this course, you will be having enough amount of queries. Okay. So yeah, somebody has asked. Please, again, just 1 second. Somebody has
Please
said,
please
please
cover
cover
BJT and MOS.
BJT and MOS.
That will
Okay,
be
okay,
covered.
okay. Yeah, yeah, those things definitely it will be covered. Presently, what they are doing is more like prerequisite of this course. Okay, so say for example, if you see the present circuit, which is displayed on Sajid's slide, it is how combine a target DC voltage and a signal. So the signal source it is having 5 volt DC, and then you like to have a signal which may be having different DC levels you are looking for some reason in later circuit. So the right side branch it is generating the DC voltage through this potential divider, and then left side circuit it is feeding the signal through the AC coupling capacitor or DC decoupling capacitor. So this kind of arrangement it will be used in our say BJT circuit where uh, we'll be having separate bias circuit or biasing circuit, and we'll be having separate signal source and signal it will be coupled through capacitor, right? And definitely we'll be going detail in BJT and MOS. Any other query? Okay. Okay, so by default, I'm assuming that Sajid and Sharada will be there on Monday and Tuesday. In case if it requires other two TAs from here, they may participate if it requires, and if there is any outstanding queries, if it is not getting addressed satisfactorily by other TAs, definitely I can chip in. But of course, I do not want to directly interfere with the other TAs flow. So that is my plan. So feel free. I'll request all the participants to feel free to share your suggestion and comments. Okay. Yeah. So that's all from my side. Sajid, you may continue, and Sharada, do you have any other suggestion, Sharada?
No, sir, but if you feel anything we can do, please feel free to let us know because, anyways, we have to give 2 hours. So,
Hmm.
whatever you feel like. So, for now, Hindi and English is like one option. if
Hmm.
something other we can do, because the 10 questions are we can deal them sufficiently in 2 hours,
Hmm.
with going completely to the depth also, and
Okay.
we
Okay.
can deal with them. So
Hmm.
dividing the questions will not make much of an impact. Or otherwise, if we are going for same content, then students can decide whether they want to join the one session or
Okay.
other, depending on their preference. So
Okay.
whatever
Okay.
feels. Yes, sir.
Okay. Okay. So right now let we proceed with English and Hindi versions, Monday and Tuesday. Later, if situation demands, probably we can decide uh, how we can distribute the questions and to what depth we can go. And let also the participants come up with their own queries as well, which may be taking some more time. But right now they do not have any other so strong queries. So probably we are thinking all the 10 questions may be covered in one day itself. But later that may not be the situation.
Yes.
Yeah. Okay.
Okay, sir.
Okay then. So I'll take a leave now. Thank you.
Thank you.
Yeah.
Bye
Please
bye.
continue. Yeah. Please continue.
So, hello everyone again. So, let's continue with. There will be some students who may have missed the last session, right? So, let's just discuss these questions quickly. So, what is the question here? We have to find a DC voltage at output node. So, what? Okay, let me ask this question to everyone here. What happens? How does the capacitor behave when you have the variation frequency, input frequency? Anybody?
Sir, it blocks the DC part.
Okay. And about AC, and how does it behave with
It
short
gets
circuit?
short
Short
circuit.
circuit.
So it depends on circuit actually, how your resistors and are connected and something. So it depends on a particular frequency after which it behaves as a short circuit. So how is reactance of this capacitor given as? Anybody knows the formula?
1 upon omega c.
J omega c, right?
Yes, sir.
Magnitude is given as 1 by omega c, right? So it is inversely related to frequency, right? So it won't be exactly, if for example DC, it will be open, that is for sure, but it will start acting as a short at a particular frequency, after a particular frequency, right? That depends on the circuit, how your elements are connected in the circuit. So we will see this question. The question was uh, to find a DC voltage. How, what is, first let me put another question. What is the equivalent circuit? And how do you make an equivalent AC equivalent circuit and DC equivalent circuit? So do you know about that? So if we have to make an AC equivalent circuit of this total circuit, what will be the step you will take?
Sir, we will remove all the voltage sources and ground them.
So why do you do that, and how you think that the final result will be same, which is the exact result? Which principle you follow?
We are, sir, following superposition principle.
Yes, right. So what is the superposition principle that if you have AC sources and DC sources, you can find individual answers by using DC separately and AC separately, right? So if we have to find DC voltage at output node, what will we do? We will short AC, right? And since we are applying DC now, the capacitor will block the DC voltage. So our final equivalent circuit, how will it behave as? You will have a supply, right? If you have capacitor here, it will act as a block, and you have supply here. I will not find the solution now as it's already shown yesterday. I will just make the equivalent circuit to let the people know how DC and AC equivalent circuit will act like. Since this will also act as a open, right? Let me know if I did something wrong here. This is the output. Is it correct circuit, everyone? Hello? Is it a DC equivalent circuit correctly drawn, or is something is wrong here? Hello, am I audible?
It's fine, sir. It's correct.
Can anybody else speak? Only you are speaking here. And everybody else understand this?
Yes, sir.
Okay, so it's fine with everybody. So this is a DC equivalent circuit here. Now, can everyone draw AC equivalent circuit of this? I will just have this diagram here. Can everybody draw AC equivalent circuit?
Yes, sir.
Okay, so what is the step you will do? There are a lot of students here. Please, I will not solve this
DC
question.
volt,
I will not solve this question if you will just draw the circuit and move on from this question. Just draw the AC equivalent circuit of
capacitor
this.
gets
Okay, capacitor
all the
gets.
DC voltages get grounded and capacitor gets shorted.
Right. So your DC voltage will get grounded. So 50 ohm resistor will get connected to this node, right? If you this is node A, so your AC will be connected to this will get grounded. This will get connected through a 50 ohm resistor, right? And you will have a 12 this 500 ohm here. This will be grounded, right? This is fine. And what will happen here?
Sir, it will be short circuited.
It will be short circuited. But here
Yes, sir.
we have assumed here is that WA, this is a input frequency. It is large enough to make it short, right? Okay. So it won't be short. For example, if I have a 1 kilohertz frequency, 1 kilohertz means it's F. So it's not necessary it will be short at 1 kilohertz frequency. So there is one question here while you have to calculate the input frequency after which the capacitor will act as short. So this is what you know now. Okay, so something about diode. So everybody, what is a diode and how does it work?
Sir,
Yes.
sir, since we were discussing that previous question, the capacitor does not work, well, does not get shorted at some frequencies. Can you please explain on that point?
Okay, so this is your reactance for a capacitor, right? Right?
Yes, sir.
Okay, so how will it behave as a frequency? Like this. If you have y is equal to 1 by x, how does it behave? Like this, right? At low frequency, if I call this as 1, y is equal to 1 by f. Xc is the reactance. It's the resistance that is in simple terms, we say that it is a resistance offered by actually it's a reactance. I should not call it as a resistance, but just for understanding purpose, resistance offered by capacitor. Don't Please don't think it's a resistance, it's a reactance. It's called as a reactance. So what will happen is that it is an inverse relation. So if you have capacitor, now you have DC voltage. Okay, now you apply a DC voltage here. Let's say I have applied, wait a second, I have one more page. So let me connect one. Okay, now it is a capacitor. This is a DC voltage of 5 volt. What will happen? Initially you have not connected any supply. initially the current will be 0, right? So whenever at this undergraduate level, we usually what we do is that we consider it as a steady state. That's why we say it is blocking the DC voltage. But what actually happens is that when you will connect this 5-volt supply, what will happen? This capacitor, Q is equal to CV. Everybody, do you know that Q is equal to CV? What will happen is that initially the current is 0, but what will happen is that due to this connection of 5-volt supply, the small amount of current will flow, and these capacitor plates will get charging, right? It's initially the potential will be equivalent to 0, right? And what will happen is that you may have seen let me just write a formula for capacitor. It's somewhat like uh, 1 minus something like exponential relation. I may have to derive it, t by tau. So time is in tau is the time constant for the resistor, where tau is equal to RC. We don't need to go in detail in later to this. We may have some information in next few lectures. So just for understanding, what happens is that the capacitor starts charging and its potential will start raising, and it will reach ultimately to 5 volt. So that's why it gets fixed at a 5-volt supply after a particular time, which is called as a time constant. And when this is 5 volt, this is 5 volt. So as we saw from current across resistor, it is V1, it's V2. Initially it would have been V1 minus V2 by some R. Now initially the capacitor was uncharged, therefore it would have been V1 minus 0 by R. Some current will flow, and then this potential starts rising down. The final will be 5 minus 5 by 0, the 5 minus 5 by R, that will be 0. So current starts to drop. So it takes some time. Similarly, now if you have frequency as well, this frequency will change its blocking nature, and it has a relation that is inversely proportional to the frequency. Actually, you saw the formula Q is equal to CV. Now if you look at the current will be equal to C dV by dt. Now if you have this voltage which is changing with time, if you have this voltage that is changing with time, then then you can say that there can be a current across capacitor, which ultimately depends on frequency, as I said, omega c. So it will behave in this way. So at a very high frequency, what you can say that xc equivalent to 0, which we say that it is a short. So you will see one question, we will discuss that question, where you will find that is equal to cut-off frequency or cut-in frequency we can have for a capacitor in a particular circuit. So was there anything else in this question? Okay, so if we assume now the capacitor is shorted for the input signal frequency, we are already considering that the capacitor is shorted. So has everybody drawn the small signal equivalent circuit? We call it as AC equivalent circuit. It's also called as a small signal equivalent circuit. So has everybody drawn it yesterday or at your places? Or I can draw here too. Hello? Hello?
Yes.
So
Yes.
should I draw AC equivalent circuit, then you can follow in your places?
Sure, sir. Sure, sir.
Yes, sir.
Capacitor will act as a short, and you can draw it as a 500 ohm. You have 50 ohm here. Please pardon me for my handwriting, it's not very good. Okay, now you have to find this voltage. So this is a AC equivalent circuit, right? So you short the DC in DC voltage, or you ground them, and now you have to find that it is easy now, right? This is in parallel, then this is in series, so you can do this question now.
Sir, it's not 500, it's 50 only.
Now it's 500, right? This one is 500.
Oh,
This is
sorry, sir.
this one, right? You can, I have just it was, maybe you got confused. It is 0, right? You can, it is on the same node. I have just made it here, so it's not an issue, right? So what how do you define, how do you define resistors in parallel? How do you define resistors in parallel? So resistors are in parallel if they have common nodes, right? Here the, if I define it as A, so this A node has resistor 500 ohm, and it has another one as a 50 ohm. So if you have common node and your ground is also common, then you can define them as a parallel. So you can draw it anywhere as long as they are in parallel, right? Okay, now let's move on to diode. So how do you, what do you understand about diodes? So what is a diode? Let me ask first this question. As a device physics point of view, what is a diode? What is it made of? Anybody can answer about it?
It is, sir, made up of two junctions, N and P.
Not junction, it's a single junction.
Sorry, sir, it's a single junction with N
So
and P.
what is
It
an,
it
mhm.
is a unidirectional device.
Vivek, you are not audible.
It is a unidirectional device.
By unidirectional, what do you mean by unidirectional?
Yes, sir.
You mean unidirectional as in the current flows in one direction and stops in other direction, right?
Breakdown of other direction.
You are not audible, Vivek. You can type in the chat box. So Arjun, you were saying that it is a P and N junction, right?
Yes, sir.
So you want me to everyone want anybody or someone interested? I may show something more about diode.
Sir, basically it allows only current to flow in one direction only,
Okay, okay.
and in other direction it blocks the current.
So do you guys want me to discuss some things about diode, a physics point of view?
Sure,
How,
sir, we can.
okay, so how it's made of and how it works, right? So I won't be going in the equations. So let just to give you a brief idea what diode is actually. So you have already done these questions, so we can discuss for some time about it, right? So diode, as Arjun correctly said, it is a PN junction. What is P and what is N? These are types, right?
P type,
Types,
N type.
types of semiconductors. What is a semiconductor? Everybody understand what semiconductor? This course is analog circuits, and the basic elements we use in analog circuits are semiconductors, right? So everybody understands what semiconductors are. You have
Yes, sir.
you have
It's in between conductors and insulators.
you have conductor, you have semiconductor, you have insulator. What do you understand by in between? In between in terms of what?
So their properties can be
It has
enhanced by dipping.
Okay, one.
So
Okay,
conductors are already conducting, but insulators can't conduct.
okay,
But semiconductors can be made to conduct by doping them.
okay, nice. So, do you understand also in terms of band gap? No.
So three electron volt energy gap.
So that depends on type of material. In general,
Yes,
you may not have studied it. Can you turn off your mic, please?
yes.
There is a noise.
Immunity system.
Okay, thank you. So in conductors, when you talk of band gap is important to actually describe whether a material is conducting, semiconducting, and insulating. If you have no band gap or a small band gap, it can follow in the category of conductors. Like we have, oh, someone is joining now. So it can fall in the category of conductors, right? So in semiconductors, what we have is that we can have a band gap that is small enough to conduct, right? Okay, that is small enough to conduct and large enough to not conduct as like conductors do, right? So you have silicon, you may have heard about silicon, germanium, and similarly when you go higher in your studies, there are further semiconductors like you have silicon carbide, you have gallium nitride, like that. You don't need to worry about these. Just for some information, we have these semiconductors which have a particular band gap which help the device to conduct. And in PN junction as well, we have, let's say, we usually study about silicon junctions, right? So what is P and what is N? You put exactly said these are doped devices, doped materials. Why are people joining so late? So these are doped materials, right? What is doping? Doping is that if you have material which has some atoms which is neutral first, right? So what is P? P is that if this was a silicon material, this is also a silicon material. These are silicon atoms, let's say. Just it's a pictorial representation. If you want to make it a p-type doping, p-type material, that is it has less number of electrons, so you dope it with materials such as boron family. You have boron family, right? Similarly, you have family, this is boron aluminum. So what is the boron gallium, what is the five, which one is the five family? Anybody?
P type, sir. P type,
No,
sir.
if you want to make it as an N doping material, which family, with
Yes,
which family you will dope it as? Fifth family, right? So what is the,
nitrogen.
does phosphorus lying in that family? So anyway, so you have aluminum, such as, let's say, aluminum. Aluminum has 3 plus valency, right? So you will dope this material with aluminum, and silicon has 4 electrons. What will happen is that aluminum will replace silicon and it will have 1 electron less, right? Similarly, in n-doping materials, n-doped silicon, you will have silicon replaced by an atom which has 1 more electron. So in nutshell, what will happen is that in p-type you have less electrons, and in n-type you have more electrons, right? Is it understood?
Yes, sir.
Okay. So now when you connect these two, when you connect these two. So for the understanding point of view, if you have two water levels, right? So if one water level has high amount of water and other has less, so water will flow from high to low, right? Right? So same will happen here. The electrons will flow. When you connect these two, P and N, this is P and N, you have not connected any bias. So from wire to wire electrons will flow. Now you have understood why are more electrons and why are less electrons. So what is the flow of what is the direction of flow of electrons? Anybody?
Sir, it depends on the biasing.
No, no. As I said, initially you have n
So
pack.
from higher concentration to lower concentration.
Okay, right, yes. So initially, when these were not connected, right here, these are not connected yet. Fine. So if you had two water tanks, one has a large amount of water and another one has less amount of water. So water won't flow. But when you connect these two, so water will obviously flow from higher water level to lower water level, right? So same will happen here. Without any bias, if you connect these two, for some time, the electrons will flow from N to P because N has more number of electrons and P has less number of electrons. So what will happen is that there will be a development of a potential here. You have watched the lectures and studied about the cut-in voltage, right? Right? You have followed the lecture.
Yes, sir.
Okay.
Yes, sir.
So in layman's language, this is called as a built-in voltage, which you say that as the blocking voltage of diode in forward bias. So in order to for the current to flow, you have to obviously without the bias the current won't flow. But this is this knee voltage, and you can understand it for time being. What you've studied in lecture, this cut-in voltage, it is because of this. The electrons flow from N to P. There is an internal electric potential development that comes because of internal electron flow for a particular time. It takes a particular time when you connect these two materials. So it is also called as a built-in voltage. So this was regarding the cut-in voltage. Now you know now this is a diode. Now if you connect zero bias here, you don't have any bias here. So electron won't flow, right? There is because there is a potential from this direction to this direction. Now to make the electrons flow, you have to apply some voltage. So this is when you connect positive to positive, this is as a called as a forward bias, right? So when we say that in forward bias diode conducts, so what do we mean by that? So when you connect this positive voltage and you have internal potential here, it overcomes this potential and you have electrons flowing from this direction to this direction, and the conventional current will flow from this direction, right? So if you now apply reverse bias, if we apply now reverse bias, that is in this direction, what happens that this internal potential also increases. So this blocks your total current. That's what called as a, I won't go in a band diagram kind of thing. You will study those in your BTech only in your last semesters. So this is just a few basic regarding PN junction. Now, from the question point of view, what diode is being said as, it acts as a short in forward bias. It exactly does not act as a short because there is always some resistance associated with it, and it acts as a open in reverse bias. Now let's just uh, discuss how will these diodes behave. So anyone, So you have to plot the transfer characteristics. What are transfer characteristics? So transfer characteristics are when you change your input, how does your output change? So from the intuition point of view, how you think these diodes will behave? Anybody?
Sir, in forward bias, D1 will act as short circuit and
Okay.
D2 will act as open circuit, and in reverse bias, vice versa.
Okay. So if I have V in equivalent to 0, so what will be my V output? 0.
0.
Both diodes will not conduct, right? So if I increase V in, your D1 will conduct. This is the ideal case. It won't conduct directly from 0. We are here discussing about the ideal case. Otherwise, it will start conducting from after a particular V in, right? But here, as the ideal, it's considered as an ideal, so it will start following your Vn, V in. Because if you have short here, it is simply a resistor. It will be V in equal to V in will be equivalent to V out, because there is nothing connected where there will be potential drop, so it will be equal. Similarly, if you connect now the negative voltage here, negative will reverse bias this diode and it will forward bias this diode. So eventually it will follow the linear characteristic in opposite direction. So move on to next one. Okay, so you have solved this question yesterday, right? Is it visible?
Yes, sir.
Yes, sir.
So you want to know about more about this question? So you can do this question, right? It's not if you have done already. So just a simple thing that ideality factor depends on various phenomena which you will learn in further semesters. So you just for time being you just treat it as one. It depends on the mechanisms which actually govern your IV behavior of diode and your thermal equivalent voltage VTH is equivalent to KT by Q, where K is equal to Boltzmann constant, right? So if you have done this question, we can move on. Okay, this one. Okay, here in this question, there is a part where you have to find the minimum input signal frequency. Uh, in this question, you will need to consider capacitor as well. You cannot consider this as a short. So also here I can see this cut-in voltage. Now you know that cut-in voltage is in the diode because of the internal potential development. Okay, so you had done this question yesterday. I can go through it then.
Yes, we did it
Yes, sir.
yesterday.
Was this the last question of the session? Okay. So now general anything you want to discuss other than that. So if you have any other things to discuss, you can.
Sir, please discuss some basic EDC portion of MOSFET.
Actually, the MOSFET is a good topic, no doubt, but it will be discussed in next week after 2 3 weeks. So if you can see the uh, table of contents of this course, it will be discussed. So there will be particular dedicated lectures on MOSFETs and BJT. So you don't need to worry about it and follow the course. Uh, you will find those lectures. Was everyone available yesterday for the session? I can just now show this question to conclude, or if you want to discuss anything else. Just for the diode characteristics, let me tell you that you know that this is a cut-in voltage, but diode always has a resistance connected with it, right? So for the diode, you cannot apply a voltage that is greater than its built-in voltage. So whatever voltage you increase, the current will increase, no doubt, but it will drop across the resistors, the parasitic resistors, or you have some resistor connected in series. So don't be like that key you have all the voltage across the diode. The diode can only handle its built-in voltage. So you have seen that there is a single battery of 0.7 volt. You just assume it in terms of in replace the diode with 0.7 volt. That's what it is said, that there won't be a more potential across the diode. The diode maximum potential is cut in voltage. You will understand the diode principles once you uh, see the band diagrams of the diode, or anybody has studied about the band diagram. Has anybody seen the band diagrams of diode or something? No?
No, sir.
Okay. So it will be difficult currently to understand such things. If you are in second year, if you are in third year, as far as remember in last year's third year or fourth year, the teachers during the BTech teach about the band diagrams, you will understand the diode properly at that time. Currently, it is sufficient to know that how IV of the diode behaves. So if there is not anything else, you guys can leave. I can complete this question and end this meeting afterwards. I have to record it. Has anybody else some other question or something? Anything general to discuss? Hello. If there is nothing for you to say, or you want you have some questions, then I can continue with this question, then I can end this meeting. Anybody? No? Am I audible?
Yes, sir, you are audible.
Yes, sir.
So, this session, as a part of question, as you all guys have already done these questions, I can show the last question and we can end this meeting. So, in this question, you have is piecewise linear model to use. You have to use piecewise linear model. So, if you go by the equation of diode, you have ID is equal to I naught exponential of V applied by Vt and Vt minus 1. This is the diode equation. And anybody know why is this called as reverse saturation current? Anybody know? This is actually not a reverse saturation current. Reverse saturation current means that this is your diode characteristics. This is a reverse saturation current. Reverse current. That is in reverse bias as well. There is some current flowing through the device, right? So the magnitude of this current comes out to be almost equivalent to your reverse bias current. That's why it's called as a reverse saturation current, because in forward bias you cannot have a component which is flowing in opposite direction or in reverse direction. So it's just by name. When you will derive this formula, you will see that it depends on doping in both the regions. So it's nothing like a reverse current. It's just its magnitude is equivalent to reverse current. So what is piecewise linear model? So if you have diode characteristics which follow this behavior in modeling is you make your work easier. How you make your work easier? By approximations, right? So here this model is also an approximation where you extrapolate this behavior to cut your x-axis, that's your input voltage, and you call it as a cut-in voltage. And then you say that if you have diode, you have resistor, you have input voltage. You say that you replace it with this cut-in voltage, and this is applied voltage. You replace it with this. It is an equivalent circuit, like in first slide I said about the equivalent circuit. It is like that. It's also called as an equivalent circuit. So you will have V in, V gamma. This is equivalent to V in minus V gamma by R. This will be equivalent to your I. So if you use piecewise linear model, you have to replace it with this is in ideal case you will replace it with simply V gamma, or if it is a realistic case, then you will add some part of resistance as well, because you cannot have any component which is without a resistance. There is always some resistance associated with the device. So now the question was to find the diode current using piecewise linear model with cut-in voltage 0.7, assuming non-ideality 1 and thermal voltage 0.025. Fine. We have to find current. Since both diodes are in series, so plug in now. Both diodes are in series, so in series the current remains same, right? So since we have to calculate DC current, what we will do is that DC equivalent circuit, right? So what we'll do is that we will remove this. Okay, we will have only this, and this will act as open for DC case. So what we will do is that we will have 12-volt supply, and we will have two diodes in series. So this is equal to I diode 50 ohm. Okay. Well, sorry, this is 6K. Now the given cut-in voltage is 0.7. So what you will do is that you will replace it with two batteries of 0.7 voltage, right? This is 12. Now, as said in first slide, you have Kirchhoff's voltage law. So it will be applied on the circuit. Now you have increase in potential, so plus you will have drop in potential, so current I inflowing, so minus I times 6K. You again have drop in potential minus 7, again have drop in potential minus 7.7, and total will be equal to 0, right? So you have 12 minus 1.4 equivalent to I times 6K. So your current will be basically equivalent to 12 minus 1.4 divided by 6K. 10.6 divided by 6K. It comes out to be equivalent to around 1.8 milliampere. So this is the current that flows through the diode. It is a DC component, right? So next is you have to find DC output voltage. Now, if you look here, if we treat it as a simple batteries, so output voltage, can anybody just directly say what will be the output voltage here?
1.4
1.4, right? It will
volt
be
hours.
0.7 volt, 0.7 volt, right? So it will be equal to VDC, output will be equivalent to 1.4 volt. So, but if you have realistic diodes, realistic diode means you will replace this diode by some resistance as well. What you will do in that case? You know the current flowing. You can calculate the voltage drop, right? Right. Now let us just derive what will be the, what is this RD? What is this RD? You know what is this RD? This is the dynamic resistance
Yes, sir.
of diode, right? Do you know how we get this expression? Can anybody suggest me how can I get this expression for RD?
VT divided by ID.
Okay, so what we do is that we differentiate diode current, right? So this is our diode current. This is V, this is neta Vt minus 1. So I differentiate it with respect to V. What we'll get is that, fine, is this correct? Into 1 by, is this correct? So this is equivalent to ID. So dID by dV will be equivalent to ID by neta Vt. Now your resistance will be equivalent to, dV by dID. That's equal to neta Vt by ID, right? Now neta is equal to 1, so your RD will be equal to Vt by ID. Fine. So now if you have realistic diode, you have RD, you have 0.7. Can you now find this RD, value of RD? What is the value of RD? You know RD is equal to Vt by ID. Now you know ID, you know VT. You can find RD now, right? But in this case, you have to find diode voltage. You have to find voltage across these two diodes. Now, as I said, these will be replaced by 0.7 volt, 0.7 volt. Can anybody tell me what is the voltage across these resistors? I will write the formula here. Direct answer, direct value. Can anybody give me direct value? What will be the value of potential from this to this? These are equal. Can anybody answer me directly? I just wrote formula as well. VT
Towards
is,
IRD plus 1.
no, I want just value of this potential.
0.7.
0.026. So, no, zero point 0.7 is across this diode. So this is a resistor. Resistance is here, given here. Formula is given here to you. So what will be the voltage here? Voltage drop here. You have everything you need. Just if you just cross multiply this, you have VT is equal to RD into ID, right? Now potential across this resistor is simply VT, right? So here the potential drop will be 0.025. Here the potential drop will be 0.025, 0.026, sorry. And they have given it as 0.025, 0.025, right? Is this fine? So total potential drop will be across these resistors. We will add them 0.05, right? So just remember that if you have diode, you replace it with a resistor and you replace it with battery. Wait a second. You replace it with battery. This will be given to you, cut in voltage, and remember that the voltage drop across this is equivalent to thermal voltage to get your answers. So you can now find DC output voltage total equivalent to 0.025 plus zero point 0.7 plus again 0.025 plus zero point 0.7. That will come out to be 1.4 plus 0.05, 1.45 volt. Is this fine? Now what is the next part in this question was to, this is done, this is done. Find the minimum input signal frequency such that output voltage is at 50 millivolt. Can everybody try drawing a small signal equivalent circuit for this? I will give you 2-3 minutes to draw the circuit. So you will then understand how to draw small signal equivalent circuits. Can everybody try or something? Is anybody trying? Or should I just draw the equivalent circuit? This is the last question for the session, so then we can end it. So I hope you know how to draw equivalent circuit, or I can just explain for a bit again. Anybody can say anything? So should I draw?
No, sir.
You are drawing yourself? You said no. Please, if you are not able to say or you're not comfortable, you can always say anything in chat box. Please don't hesitate. I will give you 3-4 minutes to draw the equivalent circuit, then we can just solve this question quickly. Has anybody drawn the circuit?
Yes, sir.
Okay. Do you want to share your screen? I can say. Or you can just explain me what I should do. Tell me, what should I do in this?
Yes, sir. Sir, uh, sir, capacitor gets sorted and all the DC sources get grounded. And
Uh,
in case of D1, we are replacing with RD, and V gamma is zero. Yeah.
so you see the question here. You have to find input signal frequency, right? So you in this
Sir,
question you have
in this
you
case,
you don't know. It's not
yes, sir.
given. It's not given. Your capacitor is considered to be short at this frequency, right? So you don't have to short this capacitor. So you while you draw this equivalent circuit, you consider capacitor. You consider this capacitor always. You only remove the capacitor when it is mentioned that the input frequency is large enough to uh, make the capacitor shorted, right? So in this question, you have to draw the equivalent circuit, and you don't have to short the capacitor. What we will do is that you keep the capacitor, you ground here, ground the DC voltage. Just a second. You ground the DC voltage. Um, this is AC. You have to keep it. Now we can say, draw the circuit. It is simple. You have AC input. You have capacitor here. You have 6 kilo ohm resistor here. We have two diodes and two diodes. Sorry, as you said. Wait a second. As you correctly said, diode as diode is replaced by battery. So in small signal equivalent circuit, what we'll do is that we will just replace the diode with resistor, right? And we will short this battery. So we will have two resistors here, RD1, RD2, right? So the question says that you have to find minimum input signal frequency such that output voltage is at 50 millivolt. So voltage, this output voltage is here. So it's a simple analysis now. Just remember that capacitor has a reactance of j omega c, and this is 50 ohm. So now you can see that these two resistors are in series and this resistor is in parallel. I will not find the values, I will just let you know how you can do this question. If I treat it as R1, this is as R2, this is XC and this is R3. R1 and R2 are in parallel. So it will be equal, I will note it as R dash, this will be equal to R1 R2 divided by R1 plus R2, where R1 is R diode 1 plus R diode 2, right? And R2 is given. So we know now R dash, so our circuit will become equivalent to R3 capacitor XC. You have here R dash. Now you have to find V output here, right? So this is V in. Now if you apply the voltage divider rule here, so what will be V out? So V out will be simply equivalent to R dash divided by R dash plus R3 and RXC are in series into V in, right? Is it correct? So now V output will be equivalent to R dash divided by R dash plus R3 plus XC is 1 by J omega C V in. Now since we have to find the minimum input signal, what we will do is that we will take the magnitude. So remember that if you have Z is equal to A plus iota B, so when you take magnitude of this, can you tell me what will be Z equivalent to?
Root A square plus B square.
Yes, yes. So Z will be equivalent to root of A square plus B square. Same will happen here. The V output will be equivalent to R dash V in, and in denominator it will be R dash plus R3 whole square plus omega C square whole root, right? So the question says that you know such that the output voltage is 50 volt. So question says the V output is known to you, V input is known to you, magnitude. So you have V output. Wait a second, I will okay. So you know V output is 50 millivolt. You have R dash, you have 200 millivolt. You have R dash plus R3 square plus 1 by omega in. Now you know that you have all the values. R dash is also can be calculated from R1 and R2. You know everything. Now you just have to solve it for W in. So the point we take from this question is that if you have to make an AC equivalent circuit, you should not just directly short the capacitor. You have to consider the capacitor. You short the capacitor only if it is mentioned, right? So is this question clear, or you have any questions regarding it?
Yes.
So anything you want to say regarding the session or something, because we almost completed all the questions, or anything you want to say or want to know? Anything you want to say? Okay, we can then meet next week. Is it fine? So should we end this meeting?
Yes, sir.
Okay, thank you. You can leave. I will just end this meeting.